We have one more problem here, so let's look at what we have. Looking at this problem, we can see that our numerator has an exponent of 3, our denominator has a highest exponent of 2, so the degree of the top is bigger than the degree of the bottom. When we see something like this, the first thing that we're going to want to do is polynomial division. We want to get it so that we have that proper form for that partial fraction decomposition. So we are going to be doing some polynomial division here in order to kind of start this whole process off. So I know that I have to use polynomial long division or the box in order to do this. So no matter what we do, we need to do one of those two, and I know that because our denominator is x squared plus 3x plus 2, and it's not just a linear factor. So I have our division, so we have x squared plus 3x plus 2. Our inside function, the thing that's on the top, 2x minus x squared plus x plus 5. So what times x squared is going to give me 2x cubed? That's going to be 2x. 2x times x squared is 2x cubed, which is what we wanted. 2x times 3x is 6x squared. And 2x times 2 is 4x. So we're going to take a second and we're going to subtract all of these things from our function. So this first part we're going to get a 0, which is what we wanted. We wanted 0x cubed, so we can kind of stop looking at it. Negative x squared minus 6x, negative 7x squared. X minus 4x is going to give us 3x. And then we take the next term down. So now we have what times x squared is going to give us negative 7x squared. That's going to be minus 7. So we get minus 7x squared. Negative 7 times 3 is negative 21. Negative 7 times 2 is negative 14. And then we have to remind ourselves that we are subtracting all of these. So we get 0x, which is what we wanted. 0x squareds, which is what we wanted. Negative 3x minus negative 21 minus a negative turns into a positive, so we have 18x here. And 5 minus negative 14, which also turns into a positive, so we get a positive 19 here. So we get 18x plus 19 as our remainder. So what we know is that our fraction here, not necessarily the integral, the fraction itself, (2x cubed minus x squared plus x plus 5 divided by x squared plus 3x plus 2 is equal to our top part, so that 2x plus 7, or sorry, 2x minus 7 plus our remainder, which is going to be that 18x plus 19 divided by what we were dividing by originally, x squared plus 3x plus 2. So looking at this piece right here, we can integrate it like normal. This piece right here is what we need to do our partial fraction decomposition on. So we're going to take a second, we're going to look at just that piece. So we have 18x plus 19 divided by x squared plus 3x plus 2. And the first thing that we need to do is factor it. So 18x plus 19 stays on the top. We need it to multiply to 2 and add to 3. So 2 and 1. So we know that these two things are going to be equaling our two fractions added together, where we have x plus 2 and x minus 1. So we are going to be taking that and we are going to be simplifying it down. So we have multiplying both sides by the denominators. 18x plus 19 is equal to a times x plus 1 plus b times x plus 2. If I think about the zeros of this, I want to look at -1 and -2 to make things easy for us. So at -1, I have 18 times -1 plus 19, -1 plus 1, -1 plus 2. So we have -18 plus 19, so we get +1, equals a is going to go to 0, and then we have -1 plus 2 is 1, so b times 1. So b is equal to 1, and we don't have to do a lot more. And then we're going to do x is equal to -2. So 18 times -2 plus 19, a times -2 plus 1 plus b times -2 plus 2. 18 times -2 plus 19 is going to give us -17. -2 plus 1 is going to give us -1, so we have -a. -2 plus 2 is 0, so b goes away completely. So looking at this, 17 is going to be equal to a. So what we know is that 18x plus 19 over x plus 2 times x plus 1 is equal to 17 over x plus 2 plus 1 over x plus 1. Okay, so now what we want to do is go back to our original problem. So we have this integral of this fraction of 2x cubed minus x squared plus x plus 5. We have x squared plus 3x plus 2 dx. We know that this is equal to the integral of 2x minus 7 plus 18x plus 19 over the original thing, x squared plus 3x plus 2. But even further than that, we know that this is the same thing as the integral of 2x minus 7 plus that partial fraction decomposition we just did. So 17 over x plus 2 plus 1 over x plus 1. So now we're going to take the integral of each piece. So the antiderivative of 2x is x squared. The antiderivative of minus 7 is minus 7x. We have 17 over x plus 2, so we're going to do the natural log. I'm going to put 17 out front because it's a coefficient. So 17 times the natural log of the absolute value of x plus 2. And then we have a 1 over x plus 1. So 1 times the natural log of the absolute value of x plus 1. And then plus c. So the only big difference here is we may have to do some polynomial division to make the problem a little bit more manageable to do that partial fraction decomposition, and then kind of go from there. Otherwise, we get this kind of too big of a function here. I can deal with 2x cubed minus x squared plus x plus 5, but it might lead to some weirdness, so we want to get rid of that extra kind of bulk in that problem.